Hello everyone. This video is on the Knewton Alta assignment for section 4.2 called Graphing Linear Equations. So in this video I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But all the objectives are the same and the structure is similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Alright, so on your assignment page you should be seeing the title, the mastery bar that tells you how far along you've gotten, the objectives. It looks like there are 4 objectives for this particular assignment. The current objective, underneath that should be a question related to the current objective. And at the bottom of every question should be seeing a feedback button, which you can send feedback to Knewton if you wish. You will not have this instructor cheat button, and it's for instructors only. But you will have this more instruction button. Right? And if you're ever struggling with a topic, try clicking on this and you'll be taken to a page with some reading or some videos to study, and you'll be given questions related to that instruction, and completing those questions is a way to progress through the assignment. Alright, so the first objective I'm seeing is recognize the relationship between the solutions of an equation and its graph. Now we're going to be just working with, at this moment, linear equations with x's and y's in them, x to the first power, y to the first power, linear equations in 2 variables only. So I'll write this equation up. We're given the equation y equals, I don't know why I'm putting parentheses, I'm sorry, y equals x minus 5. Now remember, from section 4.1, solutions of these equations are ordered pairs that satisfy them. Right? They're ordered pairs, parentheses with an x value, comma, and a y value that satisfy the equation. That when I plug in this x value for x and this y value for y, it makes the statement true. Left side equals the right side. That satisfies the equation. And these ordered pairs, they also represent points on the coordinate plane. Right, these are also points on the rectangular coordinate system. Right, so when we're asked to graph an equation, we're just going to be drawing a picture of all its solutions. Alright, so what I'm going to do off to the side here is make a little table, x, y, and then the solutions, right, the ordered pairs, x comma y. And all we're doing here is looking for, you saw this in section 4.1. So like if x were 0, right, if x were 0, y would be equal to 0 minus 5 or negative 5. Y would have to be negative 5. The ordered pair 0, negative 5 would be on, and then that's a solution of the equation. And then when we graph the equation, remember the xy coordinate plane, the horizontal axis is the x-axis, the vertical number line is the y-axis. 0 for x and then negative 5 for y, that's on the y-axis. Right, here's negative 5 on the y-axis, 0 on the x-axis. The point that's on the graph of this equation then is this point here. Right, there's the point 0 comma negative 5, right? And you'll notice that if the x-coordinate is 0, you're going to be on the y-axis. And then the other way around, if the y-coordinate is 0, you'll be on the x-axis, right? Like, what if I put in 0 for y? Then you'd have 0 equals x minus 5. Just add 5 to both sides. X would be positive 5, right? So the ordered pair 5 comma 0 would also be on this graph. So 5 on the x-axis, right? So here's 5 on the x-axis, and then 0 on the y is in the middle, right, where the origin is. And that's this point here. There's the ordered pair 5 comma 0 on the rectangular coordinate plane. And we keep doing this. You keep doing this until you see a pattern forming. And then you can fill in the rest of the infinitely many solutions. Right? Because these equations with two variables, they have infinitely many solutions. So there's no way in the world I'm going to be able to list all the solutions. So I'm just going to list enough to where I eventually see a pattern forming. And then I'll fill in the rest of the pattern. Alright, well, what if x were 1? If x were 1, y would be 1 minus 5, or negative 4. So the ordered pair 1, negative 4. Right, so 1 on the x, negative 4 on the y. That's this point here. And if you have graph paper, that would be even better. But here's the ordered pair 1, negative 4. Let's keep going like this. I'll just pick values for x. That's easier because y is solved for here, right? See how y is alone? So it'll be easier to pick values for x and solve for y. If x were 2, 2 minus 5 is negative 3. Y would be negative 3. So the ordered pair 2, negative 3 is a point on the graph of this equation. So 2 on the x, negative 3 on the y, that's this point here. And I'm hoping you can see that the points seem to be forming a straight line, and they should. Right? Remember, these are called linear equations with two variables, right? Linear is the key there. The graph should be a line, right? A straight line. I'll just put one more point in here. How about if x were 3, 3 minus 5 is negative 2, right? So the ordered pair 3, negative 2 would also be on this graph. So I go to 3 on the x-axis, negative 2 on the y-axis, and the point that lines up with them. And also, there's 3, negative 2, right? You might be able to tell that 4, negative 1 would also be on the graph, and all these points. Now, once you have enough in, now, I know you don't need that many points. Really, you only need 2 points to form a straight line. But once you have 2 points, or at least 2 points, you can draw, the line with all the solutions on it, right? All the solutions of this equation should fall along this line here, and I'm putting arrows on the ends to indicate that it goes in both directions forever. Right. But there's the line, right? The graph of y equals x minus 5. Every single point, every single ordered pair that's on this line, the y coordinate should be the x coordinate minus 5. Right. And that's exactly what they give us here. I kind of got ahead of myself. They already gave this to us. You see this in the graph here? That's what these points are. That's what this line is. It's the graph of this equation. Now they're just asking us to use the graph to determine which ordered pairs are solutions of this equation. Now you saw this also in section 4.1. Right? You don't need a graph. You can just go through and replace the x coordinates with 1 and y with negative 4 and x with 5 and y with 4 and blah, 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 and see if the equation is true, right? Is 1 minus 5 equal to negative 4? Yes. Is 5 minus 5 equal to 4? No. Is 0 minus 5 equal to negative 5? Yes. Is 0 minus 5 equal to negative 3? No. Is 5 minus 5 equal to 0? Yes. These 3 points that I highlighted are on the graph. They're solutions of this equation. They satisfy it. But that would also be an easy thing to do, is look at the graph and just see if these points are on the line that they drew. Right, is 1 negative 4. So I go 1 on the x, negative 4 on the y. Yes, that point's on the line. How about 5, 4? Go to 5 on the x, 4 on the y. That's up here in quadrant 1. That's clearly not on the line, so I didn't highlight it. 0, negative 5. 0 for x, negative 5 for y. That's this point here, which is on the line. Yes. 0, negative 3 is above the line, right? That's this point where my cursor is here on the y-axis, 0, negative 3. That's not on the line, so I didn't highlight it. And then 5, 0. I go to 5 on the x, 0 on the y, that's this point here. That's on the line. So I clicked it, right? So I'm hoping that's easy enough. If they give you a graph, right? If they give you a graph, you should be able to tell if a certain ordered pair is a solution or not. If that ordered pair is actually a point on the line, then it's a solution of the equation. And if the point they give you is not on the line, like 5, 4, is clearly not going to be on that line, then it's not a solution of the equation. Very, very simple stuff in my opinion. All right, then after you submit an answer, right, you'll be told if you're right or wrong, and then you'll get some sort of answer explanation. Please read through the answer explanations just to make sure you understand why something was right or wrong, and hopefully you can learn from your mistakes for future questions. Alright, so moving on. Alright, so now we're graph vertical and horizontal lines. So let me talk about these. Now these are equations that are going to have just one variable, but we're still going to graph them as if they have two. Right? You'll see what I mean when I go to talking about them. Right? So vertical and horizontal lines. I'll start with vertical lines. Right, vertical lines have an equation that looks like this. It's just x equals and then some number. I'll use c for a constant. Here's the x-axis, y-axis, because if you go to c on the x-axis, there's the point c comma 0, and then say here's the point c comma 1, and c comma 2, and c comma 3, and so on. You see how you get a straight line that goes straight up and down? Right? A vertical line, right? A vertical line goes straight up and down like that. Right? It's parallel to the y-axis. But this is the line x equals c, and it's called x equals c because the x coordinate is always c. For every single point on the line, the x coordinate never changes. That's a vertical line. And then horizontal lines are, the y coordinate never changes. They go straight left and right. They're parallel to the x-axis. Horizontal lines have equations that look like this. Just y equals some number c, some constant c. So again, here's the x-axis, y-axis. If you go to c on the y-axis, here's the point 0 comma c, and then 1 comma c, and 2 comma c, and 3 comma c, and whatever. Right? The y coordinate is always the same number. If the y coordinate is always the same number, and you draw a line through those points, right, you get a horizontal line. Right? It's going straight left and right. It's parallel to the x-axis. There's the line y equals c. All right. So yeah, so every equation of a vertical line is just x equals some number, x equals 2, x equals 5, x equals -1, x equals 0. And every horizontal line has an equation that looks like this: y equals 2, y equals 5, y equals 0, y equals 7, right? Just y equals some number all the time. Right? So I hope that's clear. So what they're giving us here is, graph the line x equals -7. This is a vertical line, right? The x coordinate of any point I pick has got to have, it has to have every point has to have an x coordinate of -7. So, here's -7, 0, and this is at 2, 2. I'm going to move this over to -7, 2. All right, -7, 0, -7, 1, -7, 2, -7, 3, -7, 4. Every single x coordinate is -7, as the equation states. It's a vertical line. I hope that's easy enough. Same, again, horizontal lines are just as simple, but the y coordinate's the same all the time. All right, so we're back to this. So again, we're looking at this graph here. Now, all we're asked is, here's an equation: y equals -x divided by 3 minus 1. And they already give us a graph. We're just asked, are the following points, are the following ordered pairs solutions of this equation. Now, you could just, again, you don't need the graph. You can just plug in the x value and y value, see if you get a true statement, right? If x is 0, would y be -1? Absolutely. But you also see that the point 0, -1 is on the graph of this line. If x is 3, would y be -2? Yes. And you can see the point 3, -2 is on this line. So I'll select that. Now if x is 3, y was -2, not -5. So 3, -5, and you can see on the graph, right? 3, -5 is this point down here in quadrant 4. That's not on the line, so it's not a solution to the equation. 0, -5, no, we saw 0, -1, not 0, -5. 0, -5 is not on the graph. -3, 0. If x were -3, yeah, this would be 1, then -1 would be 0. Yeah, and then you see here, -3, 0 is a point on the graph. So that's another solution of the equation. I click on it. So that should be an easy objective, I feel. All right, you actually saw basically the same objective in section 4.1, but now you have a graph to go along with it. All right, graph a linear equation in standard form by plotting points. All right, so the standard form of a linear equation has a specific look. I'll discuss that real quick here. All right. So yeah, the standard form of a linear equation in two variables is the following. Right, so standard form of a linear equation in two variables. I'm not going to write the in two variables part. It's just the following. It's some number a, right? Capital A represents some number times x plus some number b times y equals some number c. So a some number times x plus some number times y equals some number c. And in some textbooks, they require that a, b, and c be integers. And I've seen in other books where a, b, and c only need to be just any, just any real number. Just looks like this. Okay. And of course, we don't want a and b to both be 0, because then you'd have 0 equals some c, which would make no sense. Right? And yeah, all you're doing is just plotting points. I mean, it's just like any other equation. You plug in a value for x, solve for y, or plug in a value for y and solve for x, and you get ordered pairs, and you find solutions, plot those solutions. So the example we're given here, the equation from the question is 2x plus 5y equals -5. Equals -5. All right, and then very simply, I can make a table. All right, x, y, and then again the solution as an ordered pair. You don't have to have that third column if you don't want to, as long as you understand the ordered pair as a solution. Now I hope it's obvious that if x were 0, you'd have just 5y equals -5 divided by 5. Y would have to be -1. Right, so 0, -1 is a solution. And when I go to graph this, again, if you have graph paper, that might make these a little cleaner looking. But 0 for the x, -1 for the y. So that's this point on the y-axis here. And then if y were 0, the 5y would disappear, and then I would just divide by 2. X would be -5 halves, or -2.5. Right. So -1 on the x, -2 on the x, -3 on the x. That -5 halves would be here, right, between -2 and -3. So there's your what they call the x-intercept. Right? There's -5 halves, comma 0. And that should be enough. That should be enough, right? You should only really need 2 points to draw a line in, right? The rest of the solutions should fall on this line. Right? And we're going to learn something about something called slope later. You see how from this point to get to to get from the y-intercept, the point on the y-axis, to this point on the x-axis, I'd go up 1 and then left 2.5. If you kept doing that, you'd land on other points. So if I went up 1, from this point on the x-axis, if I go up 1 and then left 2.5, I'd be at another point. Here's -5 for x, 1 for y. Let's see if that works. If x were -5, this side would be, 2 times -5 is -10. Then you would add 10 to get +5, and then y would have to be 1 after dividing by 5. See, -5, 1 is on the graph. And I could keep doing this. Go up 1, left 2.5. Up 1, left 2.5. Or down 1, right 2.5. Down 1, right 2.5, and get to other points on the graph. But the reason I wanted to have this point up here, the -5, 1, is because I think on the graph that we move points around for, I don't know if we can do halves. So like the 1 point was 0, -1. Alright, there we go. And let's see, can I go? Yeah, it looks like I can go by halves. Alright, so the other one was at -2.5, 0. That's this point here, -2.5, comma 0. And those points were on the graph, and the line that they drew here looks like the line I had on my paper, and that's all we're asked to do. Just graph an equation by plotting points, and to graph a line, you only need to plot 2 points, and then the rest of the solution should fall on the same line with those 2 points. And they have a few here. Alright, next question. Alright, and then this is just not even, not an equation in standard form, but just any linear equation. It's the same concept. Just plot 2 points, and I think it's another one where you have to move. Now, y equals -4x plus 3. I'm hoping it's obvious that if x were 0, y would have to be 3, right? So I'll move this to 0, 3. There you go. And then if x were 1, -4 times 1 is -4, plus 3 is -1. If x were 1, y would have to be -1. Right? So 1 for x, -1 for y. That's this point here. That's a solution, and 0, 3 is also a solution. And then they have it automatic where the rest of the solutions are drawn in to be in the same line with those 2 points. And that should be good. Okay, it's real simple, I feel. Let's find a couple of solutions. Alright, so back to the standard form. Alright, again, I'm going to just kind of say out loud the solutions and move some points around. If x were 0, y would have to be -9. Alright, so I'll move this down to 0, -9. There we go. And then if y were 0, x would have to be 9 halves, or +4.5. So you have 4.5 for x. There's 4.5 for x and 0 for y. And that is the nice thing about standard form. You can easily find what are called the x-intercept and y-intercept. Right, point on the x-axis with a y value of 0, and point on the y-axis with an x value of 0, and then the rest of the solutions are drawn in already. Alright, next. Another linear equation by plotting points. Once again, I'm just going to speak them out loud. It's not so tough, I don't feel. Alright, here's a note. Points can only be placed on integers for this particular graph. Alright, so obviously if x were 0, y would be 1. 0 plus 1, so 0, 1. And since the denominator of this fraction on the x is 3, I'm going to just plug in a value that's a multiple of 3 for x. Right? Like if x were 3, right, the 3's would cancel. You have 2 plus 1 for y. Y equals 3 as well. So move this point to 3, 3, and just make sure that's at 3, 3 is a solution, 0, 1 is a solution, and then all the other solutions should fall on the same line as those two. Great. Alright. horizontal and vertical lines. Now remember, x equals a number is a vertical line, right? The x coordinate's always the same. So like x is always -5. So like -5, 0 would be on the graph, -5, 1, -5, 2, -5, 3. All these points would be on the graph of this line. X equals -5 is a straight up and down line, vertical line. Alright, so once again we're given an equation and a graph and then asked which of these points actually solve the equation, right, satisfy the equation, or are on the graph of the line. Is -4, 0 on the line? Yep. Is 0, -2 on the line? Yep. So I'll select these. Is 2, -3 on the line? Absolutely. Is -1 and then 7 halves is, positive 3.5. -1, 3.5 is definitely off the line, so that's not a solution of the equation. And 0, -4 is also off the line, so the only 3 I selected are the only solutions they actually have. Alright, and then one more of these. You're given an equation for a line, the graph of the line, and you're asked, are these ordered pairs solutions of the equation? Or in other words, are these ordered pairs points on this line? So how about 1, -3? 1 for x, -3 for y? Yes. -2, 0? Yes. 4, -1? Nope. 0, 2? Nope. 0, -2? Yes. Alright, very easy, I think, after you get a couple of them down. Alright, so that objective's finished. Graph by plotting points. Obviously, if x were 0, y would be 1, so 0, 1. And if x were 1, y would be 5, 4 plus 1. So 0, 1, and 1, 5 are points on the graph. Just make sure I got them in the right places. And then the rest of the solutions should fall on that same line. Very easy. And then one more of these. So again, if x were 0, y would be -1, so I got 0, -1. And if x were 1, 4 minus 1 is 3, y would be 3, so 1, 3. So 0, -1, and 1, 3, those are solutions of the equation. Grab points on my line, and the rest of the points should fall on that same line. Wonderful. Again, you see how quickly I'm going through these. You should be able to as well after a little bit of practice. Alright, now we have y equals a number instead of x equals a number. Y equals some number is a horizontal line, right? Always has the same y coordinate. And the y coordinate here is always going to be -9. So 0, -9 is on the graph. 2, -9, 1, -9. Every single point should have a y coordinate of -9 and form this horizontal line. And that's all we're doing. Easy, easy. Alright, so one more of these and we're back to having x equals some number. So this is going to be a vertical line where the x coordinate's always -9, right? So -9, 0, -9, 1, -9, 2, -9, 3, and just making sure those have x coordinates of -9 like the equation states they should, and then we go. Vertical line. Alright, and then the last problems are just more point plotting, right? Alright, so here x plus 4y equals -6. That's an equation in that standard form. Again, if you don't have to find the x-intercept and y-intercept. You don't have to plug in 0 for x and 0 for y. I just feel like they're the easy ones. You can plug in whatever you want. Alright, find any solution you want. Now, if x were 0, y would have to be -6/4, which would be -3 halves or -1.5. So 0 for x, -1.5 for y. There's the y-intercept. And if y were 0, x would be -6. Right? So you have -6, 0. -6 for x, 0 for y. There's the x-intercept. And then the rest of the points, the rest of the solutions fall on that line. Wonderful. Okay, should have just one more of these based on my progress. So x minus 4y equals negative 12. Once again, an equation in standard form. You can find any solutions you wish. I just prefer, I find it easier to find the x-intercept and y-intercept, the points where the y is 0 or the x is 0. Now if x were 0, y would have to be negative 3, or positive 3, sorry, divided by negative 4. So 0, 3 for the y-intercept. So there's the point 0, 3. And if y were 0, x would have to be negative 12. All right, so negative 12 for x. I think I got it here, and 0 for y. So negative 12, 0, 0, 3. Those are two solutions of this equation. Again, you can find other ones, but they should fall in this same line. Wonderful. All right. And that should be it for this preview version of this assignment. Now, like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are all the same. The structure should be similar. So I'm hoping that watching me or listening to me do these here helps you in some way when you work on the assignment yourself. Thank you very much for watching.